Hello, good morning, student. I hope you all are happy, healthy, and very fine at home. So, what did we discuss yesterday? We discussed about protecting group of amine as a CBZ, carboxybenzyl or carbamate, how in what condition it is introduced, at what condition it is stable, or in what condition it is removed, or where it is used in widely, that all these things we have learned yesterday about that CBZ group. So today we are going to discuss about the next point, that is the fourth group, which is also used as a protecting group for amines. As we know that amines is another important functional group frequently occurring in the organic compounds, and most of the drugs containing are amino groups in a proteins synthesis. Amino groups are occurring for the synthesis of peptides. So the main objective of the protecting group is that to decrease the reactivity of that particular functional group and to get the desired products. So that is the main purpose of protection and the deprotection. So let's begin with fourth one, that is a Boc. Boc is nothing but as a tertiary butyloxycarbonyl, used as a protecting group for amines. Just now I told you that, and this is a bulky group, and due to the bulkiness, the reactivity of that particular functional group becomes less, and you will get the desired product there. So let us see what will be the full form is already given here. Now let us observe here carefully the structure of Boc, means tertiary butyloxycarbonyl. The structure of that is tertiary butyl, then oxygen atom, carbonyl group one here, another oxygen atom, another carbonyl group O, and then tertiary butyl group. So this is the structure of tertiary butyloxycarbonyl, or it is also termed as it is just like as an anhydride. Have you heard about that acetic anhydride, acetyl group? So that type of the group is there. So it may be called as a BOC2O type, right? BOC2O type. As anhydride type of the groups are there. Now BOC group means what? BOC group, this tertiary butyl compound, we can show like this: tertiary butyl group. This is a here oxygen atom, then C double bond O, C double bond O, then O, tertiary butyl we can write. This is a 3 methyl groups are there, and that is a very bulky group. Now Boc means what? Boc means this group tertiary butyl NO C double bond O positive charge. This is called as a Boc, BOC, Boc. This group only, particularly this group is known as a Boc, means it is a protecting group, and this protection can be carried out under mild basic condition, and it can be removed under mild acidic condition, whereas it is a stable at oxidizing and the reducing reagent. So these are the what we can call the speciality of this protecting group, and this protecting group also widely used in the peptide synthesis to decrease the reactivity of amine group, and whenever it is required, whenever to get the desired product, we can easily obtain that product. So now let us consider some of the example of organic compound. Let us see here. As we know that general formula of amine is RNH2 amine group, then that will be treated with this one BOC tertiary butoxide, then O C double bond O C double bond O, then O tertiary butoxide, right? And it will be treated with base, any base you can employed here, you can use here, like sodium hydroxide or pyridine specifically, and you are going to get here, instead of RNH2 you can take for sake of convenience RNH, then R dash here, and so that you are going to get here RN R dash, then C double bond O, then tertiary butoxide. You can write like this, or in short you can write RN, then R dash BOC, Boc. You can show the compound, the resulting compound, this way, either this way or this way, whichever way you feel is easy, you can show it. And now this is a protecting amines, and the protection can be carried out in a mild acidic condition. You can use hydrochloric acid, or you can use TFA, tetrafluoroacetic acid. Tetrafluoroacetic acid means what? Fe3C, then C double bond OH. This is the name of this structure of this tetrafluoroacetic acid. Means the H plus, the source of H plus we are go get there, and you will get the final product is RN. This one is R dash NH, and side product you may get here evolution of that carbon dioxide, as well as this one is a isobutene you will get there as an side product. So what are the mechanism of protection as well as deprotection, and some of the example actually we are going to consider here. Now let us look at the mechanism for protection. Now mechanism of protection. Mechanism of protection. Here let us see here R, N, R dash, H. You are using as a base. Maybe you can use as a, let us see, as a sodium hydroxide you can use here, NaH. Or what will happen? Or pyridine you can use as a pyridine, which will abstract the proton for here and leaving the bonding pair behind. You will get R, N, R dash, minus charge over there, and this one treated with this tertiary butyloxy carbonyl, or it is known as a urethane also, or tertiary butyl carbonyl. So here tertiary butyl you can write O, then C double bond O, C double bond O, then O, tertiary butyl X. This is a tertiary group. Now what is going to happen? This negative charge is going to attack on this carbonyl, this double bond revolving around it and this negative charge on that oxygen atom, and the resulting product they will get, resulting product will be this one. Let us see here. This is the product we are getting, R, N, C double bond O, this one, right? Now after that, let us see the mechanism of deprotection. Mechanism of deprotection. Mechanism of deprotection. Mechanism of deprotection. Now this is a protecting group. Now let us see that one. R, N, R dash, then C double bond O, then this is a tertiary group. That tertiary group further treated with HCl or trifluoroacetic acid, it gives means that proton, the lone pair which is available on that nitrogen atom, easily pick up the proton, it get protonated, and the product formed will be this one, R, N, R dash, then C double bond O, H, then O, then this tertiary group, and tertiary group. After that, what is going to happen? Here the positive charge comes on this oxygen atom, because there are the 3 bonds, one with the oxygen atom and 2 with the carbon-carbon double bond, and that's why I am putting positive charge on that. Now what is going to happen? After that, this bond is breaking, the driving force breaking this bond like this and neutralizing this one, so that we are going to get here R, then N, R dash, then COH, double bond O, and here the positive charge on this carbon atom, that is a tertiary carbon atom, and it is a very, very stable one, and so that one of the hydrogen from here get what we can call it as a neutral, that positive charge get neutralized here, our carbocation get vanish, and you will get here C double bond, this one isobutane. And now here what is going to happen? This negative charge which will abstract the proton from here and then leaving the bonding pair on oxygen atom, you will get the R, N, then this R dash, then this N, H, 4 bond is there, so positive charge comes on nitrogen atom, then O minus, double bond O, right? Now finally what is going to happen? This negative charge forming double bond here, this revolving around it, and this neutralizing this positive charge, and finally you will get R, N, then NH, R dash, and plus CO2 that goes in the atmosphere. So this is a mechanism of deprotection. Now let us look at, this is a general example we have discussed right now. If you observe this mechanism carefully, you will see the mechanism is similar with the previous one if you compare with the CBZ protecting group. Now let us see here one more actual example how it is used in a peptide synthesis. So let us see, as we know that, for example, suppose we have this one alpha amino acid, this one NH2 alpha amino acid, and here you might be knowing the structure of this Yes, that is a menthronine. The amino acid is menthronine. In a previous case we have seen as a aspartic acid, right? And now we are taken here is a menthronine is a actual structure of that menthronine, and now there are 3 functional groups are there. Look at here, this is a carboxyl group, amino group, and this one is a thiol groups are there. So that type of the 3 functional groups are there. In the multifunctional group, the protection is needed, and after protection the reactivity of that particular functional group get decreased, and we can carry out the reaction or we can do the necessary carry out the reaction, carry out the transformation to get the desired product. So now here you take down this example, tertiary butoxy carbonyl C double bond O, C double bond O, then tertiary butan. Now the lone pair which is present over here is going to attack on that amino group. This and this group remains as it is, and this reaction carried out under base in protection under the base, so that you are going to get here this product C double bond O, OH, then this MES, then NH, BOC, Boc you can write here in short instead of writing that one, and after that deprotection can be carried out under the acidic condition. The H plus, the source of H plus acetic hydrochloric acid or trifluoroacetic acid, and what do you get here? You will end up, or you will get the final product will be this one OH, then NH2, then this one thick line, and then MES. That is our menthronine we are getting here. And now let us look at as a mechanism how we are getting here. Mechanism again is a so general mechanism we have seen, but let us consider again that mechanism how it takes place here. So let us see here C double bond O OH, then NH2, then this one MES, and after that treat with this one tertiary BuO double bond O double bond O, then O TBu, tertiary butyl. Now lone pair which is present on the nitrogen atom is directly attacking on this carbonyl group, and so that you are going to get here this product C double bond O OH, then here NH C double bond O, then tertiary butoxide, and here this group as it is MES. Now this is a protection. Now the D protection related with H plus, what is going to happen? Lone pair which is present on it easily attacking on that proton, and what do you get here? You are going to get here the product C double bond O OH, then NH C double bond O H positive charge over there O, then this one, and now this group it remains as it is MES. Now finally what is going to happen? Suppose this a proton is removed from here, this forming as a double bond over there, and this sigma bond forming double bond here, and this positive charge neutralizing that positive charge. Finally, after doing all these things, what do you get here? You are going to get C double bond OH, then NH COH double bond O, and this group as it is MES, right? And after that again how that this proton you can write here, lone pair will pick up proton, acidic proton, form as just like as a deuter ion, and what do you get? You are going to get here C double bond O OH as it is, then this one MES, and finally NH here H positive charge over there, then O minus C double bond O. This type of the deuter ion, positive and negative charge present on this organic species, that type of the species is called as a deuter ion, mainly in the amino acids. And now what is going to happen? These lone pair form as a double bond here, and this double bond revolving around it, and this positive charge gets neutralized. Show the arrow carefully how I am showing this arrow, because mechanism is a language of organic chemistry. If you know the mechanism, you can able to predict the product. So that where we are using as a language for communication, you can express your thoughts or whatever you want to say, you can express via language. Similarly, in the organic chemistry, mechanism is a language of organic chemistry. Those are knowing mechanism very well, they can be very good in the organic chemistry. So remember this. And now what do you get here? You will get the product here C double bond OH, then here NH2 amine group is a free, and we will get the starting compound as it is MES, right? So this is nothing but as a menthronine is one of the amino acid. With the suitable example we have seen over here. So I think let us stop today here. Remaining we will see the next time. Have a nice day. Thank you.